Did you know that every breath you take is connected to the death of stars? That the simple act of a cup of coffee cooling reveals the final destiny of the entire universe? And that the reason you can remember the past, but not the future, is the same force that determines when and how all galaxies will die? Welcome to our channel, where we explore the deepest mysteries of the cosmos. If you enjoy content that connects science and contemplation, subscribe and hit the notification bell so you don't miss our journeys through the universe. Now, dear listener, where are you right now? Perhaps in your bed, between soft sheets that still hold the warmth of your body, or in an armchair that already knows the contours of your form, shaped by hundreds of nights like this one. What time is it there? Is it night, and does the world seem quieter, more receptive to great mysteries? How do you feel in this moment, tired, curious, searching for something that will calm your restless mind while simultaneously awakening it to wonders you may have never contemplated? Breathe deeply with me. Feel the air entering your lungs, carrying oxygen to every cell in your body. Now exhale slowly and observe how this simple act already brings us face to face with one of the deepest mysteries of existence. The air you just released will never return to your lungs in the same form. It has mixed with the ambient air, its molecules have dispersed, scattered. Something irreversible has just happened, something that points to a fundamental truth about the nature of reality. I would like to invite you on a journey, a voyage through one of the most profound and enigmatic concepts that science has ever discovered, something that is happening now while you breathe, while your heart beats, while your cells renew themselves, while the stars burn in the night sky above us. It is an invisible, silent, but absolute force. A law that governs everything from the cup of coffee cooling on your table to the final destiny of all, the galaxies in the observable cosmos. Close your eyes for a moment if you can. Imagine that you are holding an ice cube in your hands. Feel the penetrating cold against your skin. What happens to it? Slowly, inexorably, it melts. The water trickles between your fingers, warm now, mixing with the temperature of your body. Why does this happen? Why does ice never spontaneously form in your warm hands? This is the gateway to our mystery. You have just witnessed one of the simplest and most profound manifestations of something that scientists call entropy. A word that carries within it the weight of time, the whisper of impermanence, the distant echo of the end of everything we know and love. Entropy, this mysterious force that made the ice melt in your hands, is the reason why there is a difference between past and future. It determines that your memories are behind you and your dreams ahead of you, never the reverse. It explains why a drop of ink spreads in water, but never concentrates spontaneously into a point. It determines why we age, why machines wear out, why the stars are born, live, and die. But don't worry, this is not a story of despair. It is a narrative about beauty, about the most extraordinary cosmic dance that brought us here. It is about how disorder itself became the architect of complexity and life. It is about understanding that, paradoxically, it is because everything tends toward disorder that order becomes so precious, so miraculous. You have probably wondered why time only moves forward. Why you can remember the breakfast you had today, but cannot remember the breakfast you will have tomorrow. Why a drop of ink spreads in water, creating hypnotic swirls of color, but never concentrates spontaneously into a point. Why we age, why machines wear out, why mountains erode, why stars are born, live, and die. All these questions have the same answer, an answer that is written in the very structure of reality. And that answer has a name, entropy. It is the reason you are here, listening to this story. It is the force that shaped every atom in your body, that allowed the first molecules to organize themselves into life, and that one day, in an unimaginable future, will take everything back to cosmic silence. Breathe deeply again. Feel the air entering your lungs, carrying oxygen to every cell in your body through a network of capillaries so complex that, if stretched out, it would cover an area the size of a tennis court. Now exhale slowly and imagine all the molecules you just released. Carbon dioxide, water vapor, traces of other substances, dispersing into the air around you, mixing with billions of other molecules in a chaotic and invisible dance. You have just participated in one of the most extraordinary spectacles in the universe, the constant transformation of order into disorder, and of disorder into a new form of order. Each breath is a microcosm of entropy in action, a perfect example of how energy and matter flow inexorably from organized states to dispersed states. But what exactly is this mysterious thing called entropy? The word itself comes from the Greek en, within, and trop, transformation, suggesting an internal change, a transformation that happens at the heart of systems. But this etymological definition barely scratches the surface of a concept that is simultaneously simple and profoundly complex. Imagine that you're in a silent library, one of those ancient libraries with high ceilings and wooden shelves that extend as far as the eye can see. Thousands and thousands of books are perfectly organized on the shelves. Each book in its specific place, each section clearly defined, fiction here, science is there, history in another corridor. There is a system, a logic, an order that allows any person to find any specific book by following a predictable pattern. This is an image of low entropy, high organization, where each element has its determined place and information is structured in an accessible way. Now imagine that a violent earthquake shakes that library. The shelves tremble, books begin to fall. Some open in midair, their pages spreading like paper butterflies. Others fall in disordered piles on the floor. Covers separate from their contents, loose pages fly through the air, sheets from different books mix in chaotic heaps. In a matter of minutes, what was once a perfectly organized system has become a landscape of apparent chaos. This transformation from the organized library to the destroyed library is a perfect metaphor for entropy. What was once order, each book in its place, each piece of information easily accessible, became disorder, mixture, scattering. The entropy of the system increased dramatically. But here's something fascinating. If you tried to reorganize that library, putting each book back in its original place, you would discover that this would require an enormous amount of energy and information. You would need to know where each book was originally, you would need physical energy to move them, time to classify them. And during this entire reorganization process, you would be spending energy generating heat, increasing the entropy of your own body and the surrounding environment. Entropy, in its deepest essence, is a measure of how spread out energy is, how mixed up things are, how far we are from perfect organization. It's as if the universe had a natural, irresistible, almost mathematical tendency to mess up everything that is arranged. But, and this is a crucial point, it's not that the universe has some conscious preference for chaos. Entropy is not malicious. It is not a conscious force actively working to destroy order. Actually, entropy is simply pure mathematics, statistics in action. Think of it this way. There are many, many more ways for things to be disorganized than organized. If you threw all the books in the library into the air 1,000 times, how many times would they fall perfectly organized on the correct shelves? The probability would be so close to zero that we could consider it impossible. But there are trillions and trillions of different ways for them to fall scattered and mixed. This is the statistical beauty and implacable logic of entropy. It is not a mysterious force that actively pushes things toward disorder. It is simply the inevitable result of probability operating in systems with many components. The universe doesn't consciously choose chaos. Chaos is just statistically much more likely than perfect order. Have you ever thought about this? That the very existence of order, of your existence, is a kind of statistical miracle? That you are a temporary island of extremely complex organization in a cosmic ocean of tendency toward dispersion. Every molecule in your body, every cell, every organ represents a temporary and improbable victory of organization over randomness. Now, extend your hand and touch some nearby surface, a table, a wall, the arm of the chair where you're sitting. Do you feel the temperature? That sensation of warmth or cold that you perceive is not just a subjective quality. It is energy in motion, energy that is constantly flowing, constantly redistributing itself. The molecules of the surface you're touching are vibrating in a microscopic and frantic dance. The hotter the surface, the more intense and chaotic this molecular dance. The colder, the slower and more organized it becomes. Temperature, scientists discovered after decades of meticulous investigation, is not just a sensation our bodies experience. It is a direct measure of how agitated the particles that make up matter are. It is a window into the invisible world of molecular activity, where trillions of atoms move in patterns that determine everything from the fluidity of water to the rigidity of diamond. And here something truly wonderful emerges. Entropy and temperature are intimately connected in ways that physicists took more than a century to understand completely. When energy spreads uniformly through a system, when particles agitate in a more chaotic and random way, entropy increases. When there are temperature differences, thermal gradients that allow energy to flow from hot regions to cold regions, there is potential for work to be done, for order to be created, for interesting things to happen. Imagine a cup of hot coffee on a cold day. The coffee is at about 160 degrees Fahrenheit. The surrounding air is at 68 degrees. There is a difference, a gradient, an imbalance. And it is exactly this imbalance that allows energy to flow from the coffee to the environment. Water molecules in the coffee, agitated by heat, collide with air molecules, transferring kinetic energy. Gradually, the coffee cools and the surrounding air warms imperceptibly. This process continues until an equilibrium is reached. The coffee and the environment reach the same temperature. At this point, there is no more gradient, no more net energy flow. The entropy of the system, coffee plus environment, has reached its maximum possible. And something interesting happens. Once this equilibrium is achieved, nothing more happens. The coffee never heats up spontaneously again. The process is irreversible. Have you ever wondered why time flows in only one direction? Why you can vividly remember what happened yesterday, but have no memory of what will happen tomorrow? Why a burned candle never reconstitutes itself spontaneously, gathering its melted wax and relighting its flame? Why a broken vase doesn't repair itself, joining its scattered fragments in a reverse dance of reconstruction? These questions touch the heart of one of the deepest mysteries of physics and philosophy, the directional nature of time. And the answer, surprisingly, is intimately connected with entropy. In fact, one could say that entropy is the reason why time has a direction, an arrow that points inexorably from past to future. Imagine time not as an abstract straight line marked by clocks, but as a powerful river that always flows in the direction of greater entropy. We are not simply carried by this river, we are the river, we are this constant transformation, this perpetual dance of order dissolving into disorder, which in turn creates the conditions for new forms of order to emerge. More than 150 years ago, a German physicist named Rudolf Clausius, working with steam engines and trying to understand why they could never be perfectly efficient, formulated one of the most important and universal laws of nature. He called it the second law of thermodynamics, and in its simplest form it states, the entropy of an isolated system never decreases. It remains constant or increases. This apparently simple law is actually one of the most profound statements ever made about the nature of reality. It tells us that there is a preferred direction for natural processes, a fundamental asymmetry in the fabric of the universe. And this direction is always toward increasing entropy, energy dispersion, mixing of what was separated. It is this law that explains why time has a direction. Every irreversible process we observe, aging, breaking of objects, mixing of substances, cooling of coffee, is an example of the second law in action. Time flows in the direction of increasing entropy because processes that decrease entropy are statistically so improbable that we never observe them, occurring spontaneously in macroscopic systems. Think of your own life through this lens. You were born as an extraordinarily complex organization of atoms, a structure of low entropy created by the even more extraordinary processes of biology. Trillions of cells organized into tissues, organs, systems that work in harmony to maintain your existence. Your DNA contains information encoded with a precision that would make the best computers seem primitive. But from the moment of your birth, actually, from the moment of your conception, entropy has been working on you. It is a gentle, gradual process, almost imperceptible day to day, but implacable in its persistence. Your cells wear out, your proteins degrade, your energy disperses. The complex structures that make up your body experience what biologists call oxidative damage, a form of molecular wear caused by the very processes that keep you alive. You age because entropy increases. Every beat of your heart, every breath, every thought that passes through your mind represents work being done, energy being transformed, and inevitably, a small increase in the total entropy of the system that is you and your environment. But here is the most beautiful and profound paradox of all. You are alive precisely because you can, temporarily and locally, decrease your personal entropy. When you eat, you are capturing organized energy, complex molecules like proteins, carbohydrates, and fats, and using it to maintain and repair your complex body structure. When you breathe, you are bringing oxygen to feed the microscopic furnaces of your mitochondria, where glucose is burned in a controlled way to produce ATP, the energy currency of life. You are, in essence, an extraordinarily sophisticated anti-entropy machine, a creation of nature that can, for a few decades, fight against the universal tendency of the universe. You can grow, learn, heal wounds, build muscles, form memories. All these processes represent the creation of order from disorder, the organization of energy and matter into increasingly complex patterns. And you are not alone in this cosmic struggle. All life on Earth is a collaborative anti-entropic project. Plants capture sunlight, low-entropy energy from our star, and use it to build complex, organic structures through photosynthesis. They take simple carbon dioxide from the air and water from the soil, and using solar energy, build complex molecules like cellulose, sugars, and proteins. Herbivorous animals eat these plants, reorganizing this captured energy into their own complex biological structures. Carnivores eat herbivores, and so on. The entire terrestrial biosphere is like a giant orchestra playing a symphony against the current of entropy, creating growing complexity, increasingly sophisticated organization. But, and this is an absolutely crucial, but for understanding the nature of reality, this anti-entropic struggle is not free. It does not violate the laws of physics. For every local decrease in entropy, like the growth of a plant, the healing of a wound, or the formation of a memory, there is a larger increase in entropy elsewhere in the total system. The plant can only grow and organize itself because the sun is constantly burning hydrogen in nuclear fusion reactions, converting mass into energy and dramatically increasing the entropy of the solar system. You can only live and maintain your complex body organization because you are constantly converting organized energy, food, into dispersed energy, body heat, and excretion products. It's as if life were a whirlpool in a turbulent river. The whirlpool seems to go against the current, creating an organized and persistent structure in the midst of the chaos of flowing water. But in reality, the whirlpool only exists because the water is flowing in the direction of the current. It doesn't break the laws of hydrodynamics, it rides them, using the flow of water to create a temporary pattern of organization. Life works exactly the same way. It doesn't break the second law of thermodynamics, it rides it with an elegance and sophistication that defy our capacity for complete understanding. Let's do a small mental exercise that may forever change the way you see the reality around you. Imagine that you have a box divided in half by a removable wall. On one side of the wall, you carefully place 100 small red balls, all organized and contained in their compartment. On the other side, you place 100 blue balls, equally organized in their separate space. Now, in a simple but profoundly significant gesture, you remove the dividing wall. What happens in the following moments is a perfect demonstration of entropy in action. The balls, which were previously perfectly segregated by color, begin to mix. Red balls begin to move to the side that was previously exclusively blue. Blue balls migrate to red territory. If you gently shake the box, this mixing process accelerates. After a few minutes of agitation, you observe the result, a relatively homogeneous mixture, approximately half red and half blue on each side of the box. The initial perfect segregation gave way to a statistically uniform distribution. The entropy of the system increased dramatically. Now, here is the question that goes to the heart of the statistical nature of reality. If you continue shaking the box for enough time, hours, days, years, will the balls eventually return to the original configuration, with all the reds on one side and all the blues on the other? The mathematical answer is yes, it is theoretically possible. There is no law of physics that prevents this spontaneous resegregation. The balls could, by pure chance, end up all organized as they were in the beginning. But here is the surprising aspect. The time necessary for this to happen would be so astronomically long that it would make the entire age of the universe, about 13.8 billion years, seem like less than a blink of an eye. We are talking about numbers so large that there are no words in any human language to describe them adequately. Numbers with more digits than there are atoms in the observable universe. This is the profound statistical nature of entropy. It's not that it's literally impossible for things to organize themselves spontaneously. It's that it's so extraordinarily improbable that we can, for all practical purposes, consider it impossible. The mathematics of probability becomes, in practice, an absolute law of nature. Imagine now a much more dramatic version of this mental experiment. Instead of 200 balls, imagine that each ball is a molecule of air in the room where you are now. There are approximately 10 molecules in a cubic meter of air at room temperature, a number so large that if you tried to count one molecule per second, it would take much longer than the age of the universe to count them all. Theoretically, there is a microscopic chance that, by pure statistical accident, all the oxygen molecules in your room would simultaneously concentrate in a specific corner, leaving you without air to breathe. There is an infinitesimal probability that all the nitrogen molecules would organize in a layer in the upper part of the room, creating an impossible atmospheric stratification. But this chance is so small that you can literally sleep peacefully. The probability is smaller than the chance of you winning the lottery every day for the next trillion years. It's smaller than the probability of all the atoms in your body simultaneously teleporting to the moon. It is, for any practical purpose, zero. Entropy teaches us something profound and sometimes disturbing about the nature of reality. We live in a universe of probabilities, not absolute certainties. Everything we consider solid, permanent, and reliable is actually a delicate and dynamic balance of statistical forces, operating on scales that our everyday intuition cannot grasp. Have you ever thought about this really deeply? That your own existence is a statistically so improbable event that it borders on the miraculous? That every molecule in your body is constantly making probabilistic choices about where to go, how to behave, with what other molecules to interact? That you are essentially a self-organizing pattern emerging from the statistical chaos of trillions of molecular interactions. And yet, here you are, not just existing as an improbable configuration of atoms, but conscious, capable of contemplating your own improbability, capable of asking questions about the nature of existence. You are a self-conscious pattern emerging from what might seem to be pure chance, but which in reality follows deep and universal statistical laws. Physicists discovered something even more remarkable when they began studying complex systems. Entropy not only describes what has already happened, but also rigorously defines what can happen in the future. It is like a detailed map of the territory of the possible, delineating the boundaries between the probable and the virtually impossible. Some futures are highly probable, like the sun rising tomorrow morning, like water flowing downhill, like heat flowing from hot objects to cold objects. Others are virtually impossible, like all the water molecules in a lake simultaneously jumping into the air, like a boiled egg spontaneously uncooking itself, like the wreckage of a crashed car reorganizing itself into a functional vehicle. This understanding completely revolutionized our view of nature during the last 2 centuries. Before the development of statistical thermodynamics, scientists thought the universe was like a giant and infinitely precise clock, completely deterministic. They believed that if we knew the exact position and velocity of every particle in the universe at a given moment, we could calculate the future with absolute mathematical certainty. But entropy showed us that the universe is more like an incredibly complex cosmic dice game, where probabilities determine overall outcomes, but there is always room for variation, for the unexpected, for the emergence of new patterns. It is a universe where absolute certainty is replaced by statistical tendencies, where rigid determinism gives way to a more subtle and interesting probabilistic determinism. Look up if you can. Even if it's a dark night, even if you can't see any stars through the ceiling above your head, know that they are there. hundreds of billions of nuclear furnaces burning silently in the cosmic void, each representing an epic battle between two of the most fundamental forces in the universe: gravity, trying implacably to collapse everything into a single point of infinite density, and the pressure of nuclear fusion, pushing violently outward with a force that can illuminate planets trillions of miles away. Stars are perhaps the most dramatic and visually spectacular examples of the struggle between order and disorder on a cosmic scale. And paradoxically, in a way that initially seems to contradict everything we have learned about entropy, they exist precisely because entropy allows and even favors their existence. To understand this, we need to go back to the true beginning of everything. In the first moments after the Big Bang, approximately 8 billion years ago, the universe was an extraordinarily different place from the cosmos we observe today. It was an incredibly hot and dense soup of fundamental particles, quarks, electrons, photons, distributed almost perfectly homogeneously through space in explosive expansion. This almost uniform distribution represented a peculiar situation from the point of view of entropy. Thermally, it was a state of high entropy. Everything was at the same scalding temperature. There were no complex structures, there were no significant differences in density or composition. It was like a perfectly mixed cosmic soup. But here arises the first great paradox of cosmology. Although the distribution of matter and energy was homogeneous, high thermal entropy, from the gravitational point of view, this represented a state of low entropy. Gravity, contrary to what our everyday intuition might suggest, prefers things to clump together, to concentrate, to form complex hierarchical structures. A perfectly distributed and homogeneous universe is, from the gravitational point of view, highly improbable and unstable. Small quantum fluctuations, microscopic variations in matter density, that emerge from the fundamental uncertainties of quantum mechanics, were dramatically amplified by the accelerated expansion of the universe in its first instance. Imagine small ripples on a balloon that is being inflated rapidly. The ripples grow along with the balloon. These density fluctuations, initially smaller than an atomic nucleus, grew to become regions slightly denser than matter scattered throughout the young cosmos. And it was here that gravity began its patient and inexorable work of cosmic organization. Regions with slightly higher density than average began to gravitationally attract more matter from the surroundings. Like stones thrown into a calm lake, these matter concentrations created gravitational wells that pulled in additional material. The more matter that accumulated, the stronger the gravitational field became, the more material was attracted. Can you visualize this extraordinary cosmic dance? Trillions and trillions of particles of dark matter and ordinary matter, initially scattered almost uniformly through space, gradually beginning to move toward each other, first forming the first microscopic clumps of matter, then increasingly larger clouds of gas, then the first structures we would recognize as precursors to galaxies. For hundreds of millions of years, a period astronomers poetically call the cosmic dark ages, these gas clouds continued to contract under their own gravity. There were no stars yet, no source of light beyond the cosmic background radiation remaining from the Big Bang. The universe was literally dark, illuminated only by the faint and increasingly reddish glow of this primordial radiation. But within these dark clouds, something magical was happening. When a cloud of hydrogen contracts under its own gravity, gravitational potential energy is converted into thermal kinetic energy. It's the same principle that makes a bicycle pump heat up when you use it. Compression generates heat. The core of the contracting cloud began to heat dramatically. As contraction continued, particles in the center of the cloud moved increasingly rapidly. Temperature rose 1,000 degrees, 10,000 degrees, 100,000 degrees. And when the temperature in the core reached about 18 million degrees Fahrenheit, something absolutely extraordinary occurred. Nuclear fusion was initiated. At these unimaginable temperatures and pressures, 4 hydrogen nuclei, 4 individual protons, managed to overcome their mutual electrical repulsion and fuse to form a single helium nucleus. This process releases a phenomenal amount of energy in the form of electromagnetic radiation and high-energy particles. This energy creates radiant pressure that pushes outward with enough force to exactly balance the gravitational attraction pulling inward. It is a delicate and dynamic balance. If the pressure is too strong, the star expands and cools, decreasing the fusion rate. If gravity is too strong, the star contracts and heats up, increasing fusion. And thus a star is born, a self-regulating nuclear fusion reactor, balancing fundamental forces in a dance that can last billions of years. Here is the profound cosmic irony. Stars exist and shine because the universe is constantly increasing its total entropy. Each nuclear fusion reaction in a star's core converts a small amount of mass into energy that eventually escapes from the star as light and heat, dispersing through space and increasing the entropy of the cosmos. Stars are, essentially, giant entropy-increasing machines. They take concentrated gravitational order, clumped matter, and convert it into thermal disorder, scattered radiant energy. Every photon of light a star emits carries with it a small increase in the total entropy of the universe. But in the process of this conversion from order to disorder, something even more extraordinary happens: the creation of heavy elements. In stellar cores, under pressures millions of times greater than anything we can create on Earth and temperatures of tens of millions of degrees, true cosmic alchemy takes place. Hydrogen, the simplest element, transforms into helium through fusion. When a star consumes all the hydrogen in its core, gravity temporarily wins, the core contracts and heats even more. Now helium can fuse, creating carbon. Carbon can fuse to form oxygen. Oxygen becomes silicon. Silicon becomes iron. All the elements that make up your body. The carbon that forms the structure of your proteins, the iron that carries oxygen in your blood, the calcium that strengthens your bones, the phosphorus that stores energy in your cells, were forged in the incandescent interior of stars that lived and died long before our solar system even existed. You are, in an absolutely literal and non-metaphorical way, made of stardust. Every atom in your body, except hydrogen, which is primordial from the Big Bang, spent billions of years in the core of a star, subjected to pressures and temperatures that completely defy our capacity for imagination. Your atoms are veterans of cosmic battles, survivors of nuclear furnaces that transform the simplest elements into the building blocks of chemical complexity. This connection between you and the stars is not poetry, it is pure physics. It is the story of how entropy, operating on cosmic scales of time and space, created the necessary conditions for chemical complexity to emerge from the simple primordial cosmos. But stars, like everything in the universe governed by entropy, are not eternal. They are born in splendor, live in radiant glory, and die, and their deaths are as crucial to the cosmic story of complexity as their luminous lives. When a massive star, say, one with more than 8 times the mass of our Sun, exhausts its nuclear fuel after millions or tens of millions of years of constant brightness, the delicate battle between gravity and radiant pressure comes to a dramatic and violent end. Gravity, which has been contained for so long by the pressure of fusion processes, finally wins decisively. What happens next defies our capacity for understanding. The stellar core, which has approximately the mass of the Sun, but is compressed into a sphere of only about 12 miles in diameter, collapses catastrophically. In less than a second, a fraction of time shorter than a blink of an eye, all this mass compresses even further, to a point where matter itself becomes unrecognizable. The density becomes so extreme that protons and electrons are literally crushed together, forming neutrons. It's as if all the mass of a mountain were compressed into the volume of a pinhead. The energy released in this collapse is so monumentally large that it can be detected billions of light years away. This titanic explosion, which astronomers call a supernova, is not just a spectacular end. It is a cosmic new beginning of epic proportions. The explosion not only destroys the star, it catapults into intergalactic space all the heavy elements that were patiently forged in the stellar core during millions of years. Carbon, oxygen, silicon, iron, and dozens of other elements are ejected at velocities of thousands of miles per second, creating shock waves that spread through the interstellar medium like waves in a cosmic lake. These elements mix with the vast clouds of hydrogen and helium that permeate the space between stars, enriching them, transforming them, preparing them for a new generation of star formation. And this time, when new stars form from these enriched clouds, they are no longer composed only of primordial hydrogen and helium. They contain carbon, oxygen, silicon, iron, all the ingredients necessary for something truly revolutionary in cosmic history, the formation of rocky planets. Are you beginning to see the extraordinary pattern? Entropy, this fundamental tendency toward disorder, actually creates the conditions for progressively more complex forms of order. The explosive death of the first stars enabled the birth of planetary systems. The violent dispersion of heavy elements enabled complex chemistry. Destruction became the mechanism of creation. Somewhere in the cosmos, orbiting a common middle-aged yellow star, a small rocky planet formed from these enriched stellar debris. This planet was exactly the right distance from its star to allow water to exist in liquid state. It had an atmosphere with the appropriate chemical composition. It had the diversity of elements necessary for complex organic chemistry. And on this planet, our planet Earth, this complex chemistry gave rise to something even more extraordinary: molecules that could copy themselves, modify themselves, evolve, the first rudimentary forms of life. Life, when you really contemplate its fundamental nature, is simultaneously a direct product of entropy and a localized rebellion against it. It arose because entropy created exactly the right conditions: a planet with moderate temperatures, oceans of liquid water, a rich diversity of heavy elements, energy gradients that could be exploited. But once life emerged, it represents an apparently opposite tendency: the active creation of order. Complexity, organization of a sophistication that makes our greatest computers seem like simple toys. Think of the simplest cell we know. It is a structure of organizational complexity that defies our capacity for complete description. Within a volume smaller than the tip of a needle, thousands of different chemical reactions occur simultaneously, all coordinated with a precision that would make a symphony orchestra conductor cry with envy. Each cell contains molecular machines that can read and interpret genetic information, synthesize proteins according to exact specifications, repair damage, eliminate waste, regulate temperature, control the flow of substances through membranes, and reproduce with a fidelity that surpasses any manufacturing system created by human engineering. And you are the result of approximately 3.8 billion years of this anti-entropic rebellion? Your ancestors, from the first bacteria that learned to capture solar energy to the first eukaryotes that developed cell nuclei, from the first multicellular organisms to the first vertebrates, from the first mammals to the first primates, all were extraordinarily successful in the seemingly impossible task of maintaining and increasing organization in a universe that fundamentally tends toward chaos. Each generation of your ancestors faced the challenge of entropy and overcame it long enough to reproduce and pass their genes to the next generation. You carry in your DNA the accumulated wisdom of billions of years of victories against the cosmic tendency toward disorganization. But always remember, this biological rebellion against entropy is not free. It has a cosmic price that must be paid. Each act of biological organization requires energy, and this energy must come from somewhere. For life on Earth, the primary source is the Sun. Our star converts approximately 4 million tons of matter into pure energy every second through nuclear fusion, dramatically increasing the entropy of the solar system to enable all the local decreases in entropy that we collectively call the terrestrial biosphere. Every time a plant grows, every time an animal moves, every time you form a thought, the total entropy of the universe increases. Life doesn't break the second law of thermodynamics. It executes it with an elegance and complexity that transform the global increase of entropy into a symphony of local order creation. And now we arrive at the mystery of mysteries, at the phenomenon that may be considered the most improbable and extraordinary in all of cosmic history: you. Not just your physical existence as a complex organization of stellar atoms, but your consciousness. The surprising and almost miraculous fact that you are here, now, conscious of contemplating entropy, capable of reflecting on your own existential improbability. Consciousness represents perhaps the greatest paradox of entropy we know. On one hand, your brain is unquestionably a biological machine that increases entropy. It consumes approximately 20% of all the energy your body uses. Glucose and oxygen are constantly burned in your neurons, producing heat and carbon dioxide that are released into the environment. On the other hand, this same brain is capable of feats that seem to defy entropic logic. It can create conceptual order from sensory chaos, can form coherent thoughts from random neural noise, can extract meaning and patterns from apparently disconnected information. Your approximately 86 billion neurons are like small cities in a communication network of unimaginable complexity. Each individual neuron receives electrical and chemical signals from thousands of other neurons, processes this flood of information through sophisticated biochemical mechanisms, and then decides, in a process we still don't completely understand, whether or not to send its own signal forward through the network. At first glance, this neural activity seems almost random. If you could observe individual neurons in action, you would see what appears to be a chaotic pattern of firing, an electrical storm apparently without structure. But somehow, mysteriously, from this apparent chaos emerges something extraordinary: coherent thoughts, vivid memories, complex emotions, the subjective experience of being you. How is this possible? How does consciousness emerge from what seems to be neural noise? The answer may lie in a fascinating concept that scientists call emergence, the idea that entirely new properties can arise when simple components interact in sufficiently complex ways. Think of an analogy that might illuminate this mysterious process. Consider a symphony being performed by an orchestra. No individual musical note, played in isolation by a single instrument, is particularly melodious or emotionally impactful by itself. A violin playing a single note is just a vibration in the air. A piano striking an isolated key is merely a specific sound frequency. But when all these individual notes are played in harmony, following a coordinated temporal pattern, something completely new emerges: music, beauty, emotion. The capacity to evoke memories, inspire feelings, create aesthetic experiences that can bring tears to our eyes or make our hearts race with joy. Music doesn't exist in any individual note. It cannot be located in any specific instrument. It emerges from the relationships between notes, from temporal patterns, from harmonies and dissonances that arise when simple elements interact in complex and coordinated ways. Perhaps your consciousness works in a similar manner. Perhaps it is like an incredibly complex neural symphony, where the subjective experience of being you emerges not from individual neurons, but from the dynamic patterns of interaction between billions of nerve cells. This perspective suggests something profound about the nature of mind. It may be an emergent property of organized neural complexity. It is not located in any specific part of the brain, but arises from activity patterns that spread throughout the entire neural network. And here is something even more surprising. Your consciousness may be creating an entirely new form of struggle against entropy. When you learn something new, you are literally organizing information into lasting neural patterns. When you create art, you are imposing aesthetic order on visual or auditory chaos. When you feel love for someone, you are creating meaningful emotional connections that transcend the randomness of casual human interactions. When you contemplate the beauty of a sunset, when you are moved by music, when you marvel at the complexity of a flower, you are participating in a type of organization that may be unique in the known universe, the organization of conscious experience. Have you ever wondered deeply why beauty exists? Why certain mathematical proportions, certain color combinations, certain sound sequences touch us so profoundly and universally? Why cultures separated by continents and millennia independently develop similar aesthetic patterns? Perhaps because we instinctively recognize in beauty a temporary victory of order over chaos, of organization over random dispersion. Your capacity to experience and create beauty may be an evolutionarily sophisticated form of recognizing and valuing low entropy patterns, rare and improbable, configurations that deserve attention, preservation, and replication. When you feel attracted to the symmetry of a face, to the golden ratio in architecture, to the fractal patterns of a coastline, you may be responding to deep signals of organization in a world that fundamentally tends toward disorganization. Your consciousness, then, is not just an accidental byproduct of complex neural processes. It may be the most sophisticated form the universe has developed so far to organize itself, understand itself, experience itself. Through consciousness, the cosmos developed the capacity to contemplate its own existence, to ask questions about its nature, to create art, science, philosophy. You are, literally, the universe become conscious of itself. You are stellar matter organized in such a way that it can experience wonder, curiosity, love, hope. You are the means by which 13.8 billion years of cosmic evolution resulted in something capable of understanding and appreciating its own extraordinary history. Let us drastically expand our temporal and spatial perspective to truly understand how entropy operates on the vastest imaginable scales. If your entire life were compressed into a single second, the history of humanity since the first civilizations would be just a few minutes. The history of life on Earth would be a few hours. The age of the universe so far would be a few years. And the future that awaits us? It would be an eternity so vast that it defies any attempt at intuitive understanding. Entropy operates on timescales that make our human existence seem less than a flash. Processes that seem instantaneous to us can take billions of years to complete in cosmic terms. Others that seem eternal and immutable may be just transitory moments on the scale of the universe. Consider the mountains you might see on the horizon if you look out your window. From your human perspective, they seem permanent, immutable, eternal. Some may have been there since before the first humans walked the earth. Their forms seem carved in stone forever. But entropy works on them constantly, tirelessly, with a patience that transcends any human concept of persistence. The rain that falls slowly dissolves the minerals in the rocks. Wind carries away the resulting microscopic particles. Thermal expansion and contraction caused by temperature changes create tiny fractures that amplify over millennia. In a few million years, a blink of an eye in geological terms, the highest mountains you can see today will be gentle hills. In a few tens of millions of years, they will be plains. Geological entropy will operate with absolute success, redistributing all that matter organized vertically into horizontal configurations of lower potential energy. Consider the continents beneath your feet. They seem absolutely solid and fixed, but in reality they drift over the Earth's mantle like enormous rocky rafts floating on an ocean of molten rock. What is today the Atlantic Ocean was just a thin crack 200 million years ago, when all continents were united in a supercontinent called Pangaea. India, where more than 1 billion people now live, was completely separated from Asia, drifting slowly across a primordial ocean. When it finally collided with the Asian continental mass, the force of the collision was so immense that it raised the Himalayan mountain range, creating the highest mountains on Earth. Geological entropy constantly reorganizes the face of our planet through plate tectonics, volcanism, erosion. On time scales of hundreds of millions of years, continents regroup into new configurations. Oceans open and close, mountain chains rise and disappear. Consider our sun, which seems so constant and eternal that practically all human cultures have worshipped it as a permanent deity. It has shone with almost constant intensity throughout the entire history of life on Earth, providing the energy that makes our complex biosphere possible. But the sun is constantly converting hydrogen into helium through nuclear fusion, gradually transforming its internal composition and slowly increasing its internal entropy. Within approximately 1 billion years, it will have become sufficiently hotter to make Earth uninhabitable for life as we know it. In about 5 billion years, the sun will exhaust the hydrogen in its core and begin to transform into a red giant, expanding until it potentially engulfs the orbits of Mercury, Venus, and possibly Earth. Then it will eject its outer layers, creating a colorful planetary nebula, and transform into a white dwarf, a dense and hot core that will take trillions of years to cool completely to the temperature of surrounding space. And the other stars you see in the night sky? Each is fighting its own individual battle against entropy, each with a destiny determined primarily by its initial mass. Smaller stars will live trillions of years, burning their nuclear fuel so slowly that they will still be shining long after stars like our sun have died and cooled. Larger stars will die dramatically in a matter of a few million years, exploding as supernovas and leaving behind black holes or neutron stars, objects so dense that a teaspoon of their matter would weigh as much as a mountain. Black holes represent perhaps the most extreme entropy-related objects in the entire known universe. They are regions of spacetime where gravity has become so intense that not even light can escape. Anything that falls beyond their event horizon, the point of no return, is inevitably dragged to the center, where the known laws of physics break down. For decades, physicists thought that black holes were perfect entropy sinks, absorbing everything, matter, energy, information, without ever returning anything to the universe. But Stephen Hawking discovered something surprising. Through quantum effects near the event horizon, even black holes slowly evaporate, emitting thermal radiation known as Hawking radiation. Paradoxically, the smaller the black hole, the more rapidly it evaporates. A black hole with the mass of our Sun would take approximately 10 years to completely evaporate, a period of time so long that the number 10 has no intuitive meaning. To put this in perspective, the current age of the universe is only 10 years. Even this incredibly long evaporation time represents only the beginning of the era of maximum cosmic entropy. We still live in a relatively young epoch of universal history when there is abundant free energy available to create complex structures, when stars are still being born, when life can thrive. But the final destiny of the universe, according to our best current understanding of physics, is a state of thermal equilibrium known as heat death or big freeze, a future where all usable energy will have been uniformly dispersed, all temperature differences will have been eliminated, all complex structures will have decayed. Imagine the universe 10 years from now, a number so astronomically vast that no comparison is possible in our human experience. To try to visualize the magnitude of this number, consider that the number of atoms in the observable universe is estimated at about 10. This means that 10 is a number with more digits than there are atoms in everything we can see. In this almost unimaginable future, the universe will be a radically different place from the vibrant and dynamic cosmos we observe today. All stars will have exhausted their nuclear fuel and gone out. All galaxies will have dispersed as the accelerated expansion of space separates their components beyond gravity's ability to hold them together. All black holes, including the supermassive ones at the center of galaxies, will have completely evaporated through Hawking radiation. All ordinary matter, protons, neutrons, electrons, will have decayed into more fundamental particles. Assuming current theories about matter decay are correct, the universe will be cold, with a temperature approaching absolute zero. It will be dark, with no light source except occasional flashes of high-energy radiation from rare decay processes. It will be almost empty, with elementary particles separated by distances larger than entire galaxies today. This is the somber but logically inevitable prediction of modern physics for the final destiny of the cosmos, the big freeze or heat death, the thermal death of the universe. It will not be a catastrophic collapse like a big crunch, but a gradual and inexorable fading toward absolute thermal equilibrium. In this final state, entropy will have reached its maximum possible value. There will be no more temperature gradients to generate useful work. There will be no more density or compositional differences to create interesting structures. There will be no more energy flows to sustain complex processes or life of any kind we can imagine. It is a vision that may seem deeply depressing at first glance. All the cosmic drama, all the beauty of spiral galaxies, all the complexity of life, all the magnificence of human consciousness, everything eventually silenced by cold and darkness. But even in this apparent end of everything, something fascinating remains: quantum fluctuations. Even in the most perfect vacuum, even at the temperature closest to absolute zero, Heisenberg's uncertainty principle guarantees that small energy fluctuations will occur spontaneously in the fabric of spacetime. These fluctuations are normally tiny and extremely short-lived, but on unimaginably vast timescales, periods so long that they make the current age of the universe seem insignificant by pure statistical chance. Some of these fluctuations might be large enough and last long enough to create particles, atoms, or even more complex structures. Some physicists speculate that, given literally infinite time, random quantum fluctuations could eventually recreate not just individual particles, but complex configurations of matter. Perhaps even organized structures that we might recognize as conscious observers, what some theorists call Boltzmann brains, formed by pure statistical coincidence from quantum chaos. It is a simultaneously fascinating and deeply disturbing possibility that you, now, at this moment, might be one of these random fluctuations in a universe already dead for eons beyond counting. That all your life experience, all your memories, all this moment of contemplating entropy, might be a temporary pattern of low entropy emerging by pure chance from the thermal equilibrium of a cosmos long since silenced. But even if this were true, and it is important to note that this is pure theoretical speculation, would it fundamentally change anything about the reality and value of your current experience? You would still feel, think, love, suffer. The extreme statistical improbability of your existence would not make it less real, less significant, or less valuable. In fact, it would only intensify the miracle of being conscious, of being capable of contemplating these questions, of experiencing beauty and meaning in the midst of a cosmos that might be fundamentally random. And there are other speculative possibilities for the distant future that some physicists consider. Some theories suggest that space-time itself may not be stable on extreme timescales. Perhaps the quantum vacuum could eventually decay to an even lower energy state, creating a bubble of new type of physics that would expand at the speed of light, potentially giving rise to a new kind of universe with different physical laws. Other theories contemplate the possibility of cyclic universes, where periods of expansion are followed by contractions, perhaps leading to new Big Bangs and restarting the entire cosmic process. Still others speculate about the existence of multiple universes, a multiverse, where our observable cosmos is just a small region in a much larger and more complex reality. But all these speculations about the distant future and alternative destinies don't change the fundamental fact. We live now in an extraordinary epoch of cosmic history, when entropy has created the conditions for complexity, life, and consciousness. We are witnesses and participants in a unique moment when the universe developed the capacity to know itself, through observers like us. In recent decades, a silent but profound revolution has been transforming our understanding of entropy and its relationship to fundamental reality. Theoretical physicists have begun to suspect that entropy is not just about thermal energy and mechanical disorder. It may be fundamentally related to something even more basic and fundamental: information. This perspective suggests a radical view of the universe, that reality at its most fundamental level may be made of information, with matter and energy being just different manifestations of informational processing. It is an idea that would completely change our understanding of everything, from subatomic particles to black holes, from consciousness to cosmic destiny. Consider that every particle in the universe carries specific information about its state, its position in space, its velocity and direction of movement, its quantum spin, its electrical charge, its energy. When particles interact, when they collide, attract, or repel each other, this information is processed, mixed, transformed in ways that follow the laws of physics. The entire universe in this informational view would be an incredibly vast cosmic computer processing information on scales, ranging from individual quantum interactions to the evolution of entire galaxies. Every physical event would be a computational operation. Every natural process would be an algorithm being executed by the hardware of physical reality. Entropy, then, would be a measure of how much information is hidden or mixed in a system. When you break a ceramic vase, you're not just increasing mechanical physical disorder, you're scattering and scrambling the information about the vase's original form among trillions of fragments. Sound waves, vibrations in the table, heat generated by the impact. This information doesn't disappear. Information conservation is a fundamental principle of quantum mechanics. But it becomes practically inaccessible, dispersed among so many microscopic degrees of freedom that it would be impossible to recover it and reconstruct the original vase. Even in principle, this informational perspective on entropy has implications that extend far beyond academic physics. It suggests that processes we traditionally thought were purely physical may have profound computational aspects. Have you ever considered that every thought passing through your mind can be seen as an information processing operation? That your consciousness is a continuous flow of bits being organized, reorganized, interpreted, and integrated into patterns that create your subjective experience of being you. When you form a new memory, you are literally decreasing the local informational entropy of your brain, organizing neural data into specific and lasting patterns that can later be accessed and read by recall processes. When you forget something, you are allowing this organized information to gradually disperse, increasing the informational entropy of your neural system. Some neuroscientists and philosophers of mind suggest that consciousness can be defined precisely as the capacity of a system to integrate information in complex ways and create a unified experience. You would be conscious because your brain can gather information from multiple sensory and cognitive sources and synthesize it into a coherent narrative of experience. This integrated information theory proposes that different degrees of consciousness correspond to different capacities for informational integration. A simple thermostat integrates only information about temperature. A computer can integrate more complex information, but in a purely algorithmic way. A human brain integrates information in a way that generates subjective experience. If this perspective is correct, then the evolution of consciousness can be seen as the universe developing increasingly sophisticated capacities for information processing and integration. You would be the result of 13.8 billion years of development of increasingly advanced natural computing technologies. And this leads us to a fascinating question. If the universe is fundamentally informational, if consciousness is information processing, then what does it mean to create, store, and transmit organized information? When you write a poem, you are creating informational patterns that didn't exist before in the universe. When you teach something to someone, you are copying and transmitting specific information organizations from one neural system to another. When you create art, you are organizing visual or auditory information in ways that can generate aesthetic experiences in other conscious observers. All these activities represent local and temporary victories against informational entropy. They are ways of creating conceptual order, meaning, lasting patterns of organization in a universe that statistically tends toward information mixing and dispersion. If we accept that the universe can be seen as a cosmic computer processing information, then life represents perhaps the most extraordinary computational phenomenon we know, a type of computation that not only processes information, but creates copies of itself, modifies its own programs, and evolves over time toward increasingly sophisticated computational capabilities. Every cell in your body is like an incredibly advanced molecular computer, processing genetic information and responding dynamically to the environment through biochemical signaling networks of a complexity that surpasses any artificial system we have created. Your DNA is essentially a program of approximately 3.2 billion letters of code, executed by molecular machines, ribosomes, enzymes, regulatory proteins, of a precision and sophistication that challenge our engineering capacity. But unlike the computer programs we write, which are static and always execute the same operations, life software is dynamic, adaptive, capable of modifying itself in response to environmental changes. It is code that rewrites itself, tests itself, debugs itself through the experience of countless generations of living organisms. Evolution, seen from this computational perspective, is an algorithm, a systematic search process in the infinite space of biological possibilities, trying to find increasingly better solutions to the fundamental problem of survival and reproduction. Natural selection functions as a feedback system, rewarding effective solutions with greater reproductive success and gradually eliminating ineffective ones. You are the result of approximately 3.8 billion years of this evolutionary computational process. Every one of your cells carries a program that has been refined, tested and optimized by countless generations of your ancestors. It is software that wrote itself through the collective experience of billions of living beings facing the challenges of existence. And this software is not just about basic biological function, metabolism, growth, reproduction. In complex organisms like you, it also codes for extraordinary computational capabilities, sensory processing, memory formation, learning, reasoning, creativity, consciousness. Your brain executes pattern recognition algorithms that can identify a familiar face among thousands in a fraction of a second. It processes visual information in such a way that you can navigate through complex environments without bumping into obstacles. It integrates information from multiple senses to create a unified perceptual experience of the world. But perhaps most impressive of all, your brain executes learning algorithms that can modify their own programming based on experience. When you learn something new, neural connections are strengthened or weakened, new circuits are formed, activation patterns are altered. You are literally reprogramming your own neural system. And now, for the first time in Earth's history, one species, ours, has developed the capacity to understand and directly manipulate life's algorithms. We can read the genetic code, edit it, even write new biological programs from scratch. We are becoming conscious programmers of evolution, deliberate architects of the algorithms that govern life. We can create organisms with characteristics that never existed naturally, develop therapies that correct genetic bugs, even speculate about the possibility of using biological principles to create artificial forms of life and intelligence. This capability brings with it responsibilities and ethical questions that our species has barely begun to contemplate. If life is computation, if consciousness is information processing, if evolution is an algorithm, then what does it mean for conscious beings to take control of these processes? We are approaching a point in history where unconscious biological evolution may give way to consciously directed evolution, where life's algorithms can be optimized not just for survival and reproduction, but for goals we consciously choose: reduction of suffering, increase of happiness, expansion of cognitive capabilities, exploration of the cosmos. But this also forces us to confront profound questions about the nature of identity, authenticity, what it means to be human in a world where the boundaries between natural and artificial, biological and technological, evolved and designed, are becoming increasingly blurred. Here we arrive at one of the deepest and most beautiful paradoxes of existence, a question that goes to the heart of everything we have discussed about entropy, order, and the meaning of life in the universe. If the cosmos naturally tends toward thermal equilibrium, toward maximum entropy, toward the final state of heat death where nothing interesting can happen, why is there so much complexity around us? Why do stars shine, planets orbit, life evolve, consciousness contemplate its own existence? The answer to this paradox reveals something extraordinary about the nature of reality. We live in an extraordinarily special time in cosmic history, a transitional period where the universe is far from thermal equilibrium. We are surfing the wave of cosmic expansion, taking advantage of energy gradients that have not yet been completely dispersed to create structures of a complexity and beauty that defy our capacity for understanding. But there is something even more subtle and fascinating happening. It seems that the very process of increasing entropy can generate complexity as a natural byproduct. When energy flows from regions of high to low entropy, when there are thermal gradients, density differences, chemical imbalances, these flows can create organized patterns and complex structures along the way. Think of a simple but revealing example: a whirlpool forming when you drain water from a bathtub. The water is following the path of least resistance, flowing toward the drain. Increasing the system's entropy as gravitational potential energy is converted into random kinetic energy. But in the process of following this fundamental entropic tendency, the water spontaneously creates an organized and beautiful structure, the spiral vortex of the whirlpool. The whirlpool doesn't violate any laws of thermodynamics. It doesn't decrease the total entropy of the system, but it represents a pattern of local organization that emerges naturally from the process of global entropy increase. It is order arising from chaos, not despite the laws of physics, but because of them. Perhaps life is fundamentally like this cosmic whirlpool, a complex pattern of organization that emerges naturally when energy flows through chemical systems far from equilibrium. A planet with the right conditions: abundant solar energy, liquid water, diversity of chemical elements, moderate temperatures, can spontaneously develop self-organizing chemistry that evolves toward increasing complexity. This is a revolutionary perspective. Complexity doesn't arise despite entropy, but because of it. The fundamental tendency toward disorder creates the dynamic conditions necessary for increasingly sophisticated forms of temporal organization to emerge. Have you ever carefully observed how snowflakes form during a snowfall? Each flake is absolutely unique, a crystalline structure of mathematical beauty that never existed before and will never exist again. They arise when water vapor condenses in cold air, following the basic laws of thermodynamics and crystallography. Nature creates art spontaneously, complex geometry, patterns of an elegance that inspires mathematicians and artists, or observe clouds forming in the sky on a summer afternoon. They seem chaotic at first glance, but follow complex fractal patterns, self-similar structures that reflect the nonlinear dynamics of the atmosphere. They are self-organized structures that emerge from the interaction between temperature, humidity, atmospheric pressure, and the convection movements of heated air. The same fundamental principle can explain the emergence of life on planets with appropriate conditions. Far from being an improbable accident that would violate the laws of thermodynamics, life may be an almost inevitable consequence of chemistry operating in open systems far from equilibrium. On a planet bathed in constant stellar energy, with oceans of liquid water containing a rich diversity of chemical elements, matter's natural tendency to explore low-energy configurations can give rise to molecules capable of self-replication. And once self-replicating molecules arise, evolution becomes not just possible, but virtually inevitable. Random variations in molecular replication generate diversity. Competition for limited resources creates selective pressure. Mutations that improve replication efficiency are preserved and amplified. Emergent complexity accumulates over geological timescales. You are the result of this cosmic creative process that has been operating for billions of years, not a statistically impossible accident that somehow violated the laws of nature, but a natural and almost inevitable product of the fundamental laws of physics operating under appropriate conditions for sufficiently long periods. This doesn't diminish the miracle of your existence. On the contrary, it intensifies it. It means that you are an integral part of the process by which the universe explores its own creative possibilities. You are one of the most sophisticated forms that stellar matter has developed to organize itself, experience itself, understand itself. When you create something beautiful, a song, a poem, a work of art, a garden, a moment of genuine human connection, you are not simply rearranging atoms in a more organized way. You are participating in the same creative process that formed galaxies, ignited stars, generated life, awakened consciousness. You are the way the universe makes art. You are how the cosmos creates conscious beauty. You are the method by which physical reality falls in love with itself and expresses that passion through acts of deliberate creation. We are approaching the end of our shared journey through the mystery of entropy, and perhaps it is appropriate now to reflect on one of the most profound and paradoxical lessons this concept teaches us, that beauty and meaning may not exist despite impermanence but precisely because of it. If everything were eternal, if nothing changed, if entropy didn't exist and all structures were permanent forever, would there truly be beauty? Would there be meaning? Would there be urgency, passion, the precious sensation that each moment matters because it will never repeat itself in exactly the same way? Consider the cherry blossom, one of the most powerful symbols of transient beauty in Eastern contemplative traditions. Cherry blossoms are considered extraordinarily beautiful partially, perhaps primarily, because they are ephemeral. They bloom in a glorious explosion of pink and white color for just a few weeks in spring, then fall like colored snow, covering the ground with petals that soon darken and return to the soil. If cherry blossoms lasted forever, if they were permanent and unchanging, would they have the same emotional impact? The same capacity to move us to tears? The same ability to make us stop in the middle of our busy lives and simply contemplate pure beauty? Probably not. It is precisely their transience that intensifies our appreciation, that makes each moment of contemplation precious and irreplaceable. Impermanence doesn't diminish beauty, it concentrates it, distills it into an experience of almost unbearable intensity. The same principle applies to our own human existence. We know, at some deep level of consciousness, that we are temporary, that our complex organization as conscious beings will eventually disperse, that one day the atoms that currently form our bodies will be scattered throughout the cosmos, perhaps incorporated into other forms of life, perhaps floating free in intergalactic space. This awareness of mortality could be seen as a source of existential despair, but paradoxically, it can also be a source of profound meaning and urgency. Knowing that our time is limited, each experience becomes more intense. Each relationship becomes more precious. Each moment of consciousness becomes more valuable. Entropy, our silent and universal teacher, teaches us about the true value of things. It shows us that creating something beautiful, even if temporary, is an act of cosmic significance. That organizing energy and matter into complex patterns, even knowing they will eventually disperse, is a way of participating in the universe's fundamental creative process. When you smile at someone, a gesture that lasts only seconds, you are creating a moment of human connection that locally decreases emotional entropy. When you create art, you are imposing aesthetic order on visual or auditory chaos. When you learn something new, you are organizing information into lasting neural patterns. When you love, you are building bridges of meaning across the existential void. These acts are not insignificant because they are temporary. They are deeply significant precisely because they are temporary. In a universe tending inexorably toward thermal equilibrium, each gesture of order creation is a small miracle, a momentary but real victory against the cosmic tendency toward dispersion. Think of the great medieval cathedrals that still adorn European cities. Their builders knew perfectly well that they would eventually fall, that time, rain, earthquakes, and gravity itself would work to undo them. But they built them anyway, creating structures of architectural beauty that have inspired millions of people for centuries. Knowledge of impermanence didn't diminish their motivation to create, it intensified it. They knew they were building against time, that they were organizing stone and space into configurations that would temporarily challenge the forces of entropy. And this battle against impermanence gave their creations a meaning that transcends their functionality. Or think of music, perhaps the art most intimately connected with the temporal nature of existence. A symphony exists only while it is being played. The moment the last note fades into silence, the music disappears completely. There is no persistent physical object, no permanent artifact. But during those ephemeral moments of performance, something transcendent happens. Order emerges from the chaos of air vibrations. Mathematics becomes emotion. Temporal patterns create aesthetic experiences that can completely transform our perspective on life. Music is pure temporal organization. Specific frequencies organized in specific sequences during specific periods of time. It is entropy being temporarily reversed in the acoustic domain, sound chaos being molded into beauty through conscious intention and technical skill. Your own life is like this cosmic symphony, temporary but real, ephemeral but significant. A unique pattern of consciousness that never existed before in the history of the universe and will never exist again after your final dispersion. Entropy teaches us cosmic humility. We are small and temporary in a vast, ancient, and apparently indifferent universe, but it also teaches us cosmic dignity. We are part of the process by which the universe becomes conscious of itself, by which inert matter organizes itself into forms capable of experiencing wonder, beauty, love. When you look at the stars on a clear night, you are not just observing light from distant suns. You are the universe looking at itself with curiosity and admiration. You are stellar matter organized in such a way that it can experience the sensation of the sublime, can ask questions about its own origin and destiny. And so we come to the end of our long journey through the mystery of entropy, but perhaps also to the beginning of a deeper and more personal understanding of our place in the cosmos and the meaning of our brief passage through consciousness. We have learned that entropy is the fundamental force that governs the direction of time, explaining why ice melts in our hands and never spontaneously reconstitutes itself, why we can remember the past but not the future, why all organized structures tend eventually toward dispersion and equilibrium. We discovered that this apparently destructive tendency toward disorder is actually the supreme creative force of the universe. It is entropy that allowed stars to be born from primordial gravitational dispersion, that enabled stellar death to spread heavy elements throughout the cosmos, that created the conditions for the emergence of complex chemistry, life, consciousness. We saw how life represents an extraordinary form of anti-entropic Rebellion, systems capable of locally decreasing their own entropy by capturing and organizing energy from the environment. And how consciousness may represent the most sophisticated form of this rebellion, creating conceptual order, meaning, beauty from the apparently random noise of sensory experience. We contemplated the final destiny of the universe, a cold and dark future where all free energy will have been dispersed. All structures will have decayed, all complexity will have dissolved into final thermal equilibrium, a perspective that could seem hopeless, but which actually intensifies the miracle of being alive and conscious now in this extraordinary moment of cosmic history. We explored the possibility that information is more fundamental than matter and energy, that the universe is essentially computational, that consciousness is a sophisticated form of information processing that allows the cosmos to know itself through observers like us. But perhaps the most important and transformative lesson that emerged from our exploration is this: entropy is not just an abstract law of physics. It is a philosophy of existence, a teacher of impermanence, a revealer of the intrinsic value of temporary organization in a cosmos tending toward chaos. It teaches us that everything is transient, that all order is temporary, that all structure is ephemeral. And far from being a lesson of nihilistic despair, this can be a source of profound existential peace and creative motivation. If we accept that impermanence is the fundamental nature of reality, each moment of order becomes miraculous. Each experience of beauty becomes precious. Each act of creation becomes sacred. You, sitting there now, absorbing these words, processing these ideas, are a unique and statistically impossible configuration of atoms that formed in the hearts of stars billions of years ago. You are a temporary form of conscious organization in a universe that fundamentally tends toward chaos. You are absolutely literally a walking statistical miracle. But it's not just about you being improbable, it's about you being necessary. The universe needed exactly 8 billion years of cosmic evolution, every supernova, every galactic collision, every genetic mutation in trillions of ancestors to create the precise conditions that made your existence possible. You are the inevitable product of a causal chain that extends back to the Big Bang entropy, which initially seemed to be about destruction and ending, revealed itself to be fundamentally about creation and transformation. It is the force that allows the new to emerge from the old, that enables growing complexity to arise from primordial simplicity. That makes it possible for consciousness to awaken from inert matter. When we truly understand entropy in all its manifestations, physical, informational, biological, psychological, we understand that we are simultaneously products and active participants in the most fundamental cosmic creative process. We are not separated from the universe observing it from outside. We are the universe knowing itself, experiencing itself, falling in love with its own emergent complexity. And this brings us to the final reflection on the meaning of conscious creation in an entropic cosmos. If it is true that we live in a universe where all order is temporary, where all structure eventually disperses, where even galaxies will separate and stars will die, then what does our capacity mean, unique as far as we know, to deliberately create order, beauty, meaning? Perhaps it means that, for a brief cosmic moment, the universe found a way to consciously rebel against its own most fundamental laws. Through life, through consciousness, through you, the cosmos developed the capacity to create local pockets of order that are more than mere, temporary victories against entropy. They are expressions of the fundamental creativity that has been operating since the Big Bang. When you create something beautiful, a painting, a song, a poem, a garden, a moment of genuine human connection, you are not simply rearranging atoms in a more organized way. You are participating in the same creative process that formed galaxies. Ignited stars, generated life, awakened consciousness. You are the way the universe makes art. You are how the cosmos creates conscious beauty. You are the method by which physical reality falls in love with itself and expresses that passion through acts of deliberate creation. Every time you choose to create instead of destroy, to organize instead of scatter, to connect instead of isolate, you are collaborating with the most fundamental forces that have shaped the cosmos for billions of years. You are continuing the story of emergent complexity that began with the first stars and may culminate in forms of consciousness and creativity we cannot yet imagine. Entropy shows us that we are temporary. But it also shows us that, during our brief moment of conscious organization, we have the extraordinary capacity to create meaning, generate beauty, form connections that transcend our individual mortality. Thank you for accompanying me on this long journey through the mystery of entropy. Thank you for lending your precious and temporary consciousness to this contemplation of order, chaos, and the profound meaning of existing in a universe that is constantly transforming. May you carry this understanding as a source of existential peace and creative inspiration, that your impermanence does not diminish your value, but intensifies it infinitely. That your transience does not make your life less significant, but makes it infinitely more precious. That knowledge that all order is temporary should not discourage you from creating, but should inspire you to create with even more passion, knowing that each act of conscious organization is a small victory against cosmic chaos. You are a unique pattern of consciousness emerging for a brief but brilliant moment from the eternal dance between order and disorder. You are the universe experiencing itself subjectively, asking questions about its own nature, creating art and science and love as expressions of the fundamental creativity that has operated since the beginning of time. When you wake up tomorrow, remember, you are made literally of stardust that organized itself over billions of years into a form capable of contemplating its own cosmic origins. You are a walking statistical miracle, an impossibility that somehow became real, a temporary but magnificent form of conscious organization floating for a moment in the cosmic ocean of entropy. And in this knowledge, perhaps you will find not despair at the transience of everything, but a deep gratitude for the impossible opportunity to be conscious, to love, to create, to participate for a moment in the most extraordinary adventure we know, the emergence of complexity, life, and consciousness in a cosmos that began as a hot and simple soup of fundamental particles and evolved over unimaginable ages to produce you, an observer capable of understanding and appreciating your own improbable cosmic history. The universe took 13.8 billion years to create something capable of contemplating entropy. You are that extraordinary creation. You are the temporary but real answer of the cosmos to the question, what is possible when matter and energy organize themselves in the most complex way imaginable? Entropy teaches us that everything passes, but it also teaches us that, while we are here, we have the miraculous capacity to create moments of order, beauty, meaning, and connection that, though temporary, are completely real and infinitely valuable. Rest well, knowing that you are simultaneously a product of the universal tendency toward disorder and a conscious rebellion against it. Dream, if you can, of all the still undiscovered forms that cosmic creativity might take through minds like yours. And now, dear listener, before you return to the contemplative silence of the night, before you let these ideas settle in your mind like cosmic sediment deposited by billions of years of stellar evolution, I leave you with one final question to carry with you. If everything in the universe inevitably moves toward maximum disorder, if all structure is transitory and all organization is ephemeral, if even stars die and black holes evaporate, what does it really mean for you, a conscious, creative being capable of love, to deliberately choose to create order, beauty, and meaning, even knowing that all of this will eventually disappear? What does this conscious choice to create in the midst of chaos reveal about the deepest nature of consciousness and its extraordinary role in the cosmos? And is it possible that, by making this choice, you are participating in something even more fundamental and lasting than matter itself, something that transcends physical entropy and touches the essence of what it means to be a conscious part of a universe capable of knowing itself?